Let's have a look at this question. And this question can be answered directly without putting your pen to the paper, but I will go ahead and take the route that probably a lot of students would have taken on this. And at the end, I'll explain you how we could have actually answered this without putting your pen to the paper. But let's understand what students go through when they solve such question. This equation, for how many distinct real values of x, this equation holds good. That's what the question is talking about. The moment students look at this, natural instinct is to look at the identities of log and try and see if this can be made a little more simpler, right? Now, if you remember the identities of log, you know this can be easily brought down to a single log. And how do we do that? We can rewrite this as x square log of base 32 16 minus of log of base 32 64 minus of x is equals to 0. This is something that you can write. Now 16 and 32, 64 and 32 all can be written as 2 to the power of something. So now this x square times of log base 2 to the power of 5, and this is 2 to the power of 4. So 2 to the power of 4 is the input value, 2 to the power of 5 is the base. Similarly, the next term can also be simplified as 2 to the power of 5 in the base, and 2 to the power of 6 is the input value of the log, and make it x equals to 0. This helps us rewrite this equation as x squared times of 4 by 5 with the help of identities of log base 2 2 minus of 6 by 5 log base 2 2 minus of x is equals to 0. Log base 2 2 will be equals to 1. So we boil down to an equation 4 by 5 x square minus of 6 by 5 minus of x is equals to 0. Now go ahead and look at this. 4x square minus of 5x minus of 6 is equals to 0. That's your quadratic equation, and you can try and solve this particular equation. 6 into 4 is 24 and 8 into 3 is also 24. So 4x square minus of 8x plus of 3x minus of 6 should be equals to 0. 4x you can take common and 3 you can take common from here. So 4x plus 3 times of x minus of 2 equals 0. So you would get down to x is equals to 2 and x is equals to minus 3 by 4. Now typically students would want to mark this as the answer as option E2. Why? Because there are two values and x is not the input value of any of the logs, so that is okay if x turns out to be a negative value as well. But the thing that they want you to consider is that they've given you a greater than 0. If the value of a is greater than 0 and a is present as a base of logs term present over here, if you go back to the basic identities of log and basic definition of log, you would realize log of base ax is equals to y is defined only if the following conditions are met. What are those conditions? X must be greater than 0, and second condition that all of us must remember is a must be greater than 0 and not equals to 1. If these conditions are met, that is when the log is defined. And when they're saying a is greater than 0, they're not ruling out the possibility of a being equals to 1. That means if a becomes equals to 1, then these two values present over here must be rejected. Why? Because the log is not getting defined, and hence the answer to this particular question must not be option E2, but it depends upon the value of a. So option C should be the answer, and this is precisely what I was saying at the beginning of this video, that if you remember this identity, then without even solving this entire question, you would be able to answer this. And this is not even an identity, this is the basic definition of log that one must remember. So option C, depends on the value of a, should be the answer for this question.